Go.
Good evening, Professor. This is Group 5. Garrett Ivester, Joseph Santa Maria, and Kyle Iristorza. And for our final project, we opted to go with option 1, and that is to provide a cloud infrastructure for a customer that is going to be switching from a physical server style to store all of their medical records into the cloud using AWS. And next slide, please. So our network diagram shows our proposed infrastructure that we are providing our customer. As shown on the bottom right corner, we have support for 3 office locations, but it is scalable if they decide they want to open more offices around San Diego. And when the customer approached us, they had 4 doctor workstations and an administrator, assistant administrator, and a database that was inside each office location. We are able to take away the physical database stored within each office location and transfer that and utilize AWS and store all of their patient records on the cloud. With our proposed infrastructure that we are providing our customer, um, we can make it so that there is one administrator that is able to do administrative changes to all office locations, the web server on the cloud, as well as the patient record database. And I will be handing it over to Garrett Ivester to talk about his portion of the project.
All right, so on my portion, we're going to talk about Amazon EC2 instances, the application load balancer integration, and access control and authentication. So we'll start with the EC2 instances, and that's going to be the foundation of this healthcare information system that we're coming up with. And it's going to provide scalable virtual servers as well as a dynamic infrastructure that can adapt to the evolving demands that the clinic might have. So if they're going to get bigger, they're going to get more patients, more employees. We're going to be able to scale up with that. It's also going to be the backbone for hosting our critical services and ensures that we can seamlessly scale, like I said earlier, with the patient care needs or more employees. We're going to be able to raise that compute capacity and scale up with them. So along with that, the adaptability of these are super important. So when you're dealing with something like, accessing patient records or something time sensitive like that, you're going to make sure that these instances are up and going, and you're going to be able to access those. And next slide. So next, we're going to be talking about the application load balancer integration, or the ALB. It's another AWS-powered system. Its capabilities ensure that any incoming application traffic is going to be evenly distributed across multiple EC2 instances. So it's not only going to optimize our resource utilization, but also enhance the overall performance of the applications. And what makes the ALB different is that it has an automatic traffic redirection feature, and that's going to ensure continuous service availability. So if an instance failure does happen, the ALB is going to detect that issue and then redirect the traffic to a healthy cluster. It's just going to greatly minimize the risk of downtime. It's going to be kind of like a traffic manager. And this is a big deal within the healthcare industry because if you're down and the patients can't access their medical records, you don't want to have that risk that something might happen that they need that information. So any chance to reduce the risk of downtime, you're going to want to take that. And the ALB helps. And next slide. Next is going to be access control and authentication. We're going to be using AWS IAM, which is Identity and Access Management. This offers a fine-tuned control over user permissions and ensures that only authorized personnel have access to the healthcare system. This is definitely important in the healthcare sector since safeguarding the confidentiality of patient records is one of the most important things you can do. Um, Along with IAM is the multi-factor authentication for our developers and admins. This is just basically be an additional layer of security beyond just the traditional passwords. So there'll be multiple verification steps, and this will significantly fortify our defenses against any type of unwanted access. This combination of IAM and multi-factor upholds industry best practices and also aligns with the strict privacy regulations that are set in place in the healthcare environment. And to kind of wrap up those couple slides, so the EC2 will form the base by having scalable virtual servers that can adapt to the demands of the healthcare clinic. And then the integration of the ALB is going to enhance the system's efficiency and fault tolerance, and also make sure that continuous service availability is paramount. With all this, we also have security covered through AWS IAM and multi-factor authentication, and that's going to be the main thing protecting the patient records. With all these, it's basically going to create a healthcare information system that will meet the standards of reliability and scalability and security that's going to be required in the healthcare sector. And now I'll be passing it on to Joseph Santamaria to talk about databases and CloudWatch.
Hello, Professor. This is Joseph Santamaria, and I'll be going over the backend database. And for our backend database, we decided on going with Amazon Relational Database Service because it is an easy to use service that integrates with many different database engines. Medical records are extremely important for the medical clinic and should always be available. With Amazon RDS's automated backup and point in time recovery, it makes it easy to store backups for up to 35 days. And with this feature, you will be able to revert back to any point in time within the current backups. Another feature that Amazon RDS has is Amazon Aurora, which is a database engine that is used alongside the database that RDS provides. Amazon Aurora has the capability to extend the database when the capacity is reaching max limit. This feature provides great scalability and allows for more clients to come into our clinic without the headache of looking for more space. I will be going over the monitoring and testing portion as well. Monitoring and testing is a very important aspect in regards to network security architecture. It is where we can react, respond, and evaluate our network for anomalies. Amazon CloudWatch uses alerts that give real-time notifications to help with a timely response. Amazon CloudWatch makes it easy to collect and store logs from our resources and applications through vended logs, logs published by AWS services, and custom logs. Logs are important because they capture detailed information about events and activities within your AWS resources. The Amazon CloudWatch logs are also important for auditing and compliance purposes, providing a trail of activities and changes made within your AWS environment. CloudWatch also provides the means to write rules to automate corrective actions whenever an event triggers it. With this feature of CloudWatch, it will take away the need to respond to tedious tasks that can be automated, shifting our focus back on somewhere else more critical. With CloudWatch constantly collecting real-time metrics for AWS resources and the use of anomaly detection, CloudWatch can help the clinic's network automatically identify anomalous behavior in our network's metric, enabling early detection of issues or abnormal patterns. And I'll be passing it on to Kyle to go over more of the security and to finish off.
Good evening again, Professor. This is Kyle Iristorza, and I will be talking about the security that is included with the technology that my teammates have provided that we are going to be utilizing in AWS. The first one I'm going to be talking about is the AWS Application Load Balancer, or ALB. Since it is an application-based load balancer, it is able to intelligently route the traffic, and it is always using HTTPS to encrypt data in transit. You are also able to configure ALB to terminate SSL and TLS and forward traffic to your backend instances using HTTP. Another another positive to going with application load balancer is that it supports many different application architectures that are already set in place. So if you're transitioning to AWS, you are most likely going to be able to use AWS and use ALB to support your current infrastructure. And ALB also removes the need for backend instance decryption, as stated with the termination of SSL and TLS traffic. Um, ALB also uses SSL and TLS certificates, and they are up to date and properly configured. The AWS Certificate Manager is used to manage and deploy SSL TLS certificates for the ALB. And as Garrett Ivester was talking about in his portion, they are also integrated with access control. And another important aspect is using the web application firewall. And AWS uses web application firewall to protect applications from common web exploits and attacks. You are also able to create your own web application firewall rules to filter and block malicious trafficking. And logging and monitoring was explained by Justin. The next portion I'll be talking about is AWS CloudFront. And AWS CloudFront is a content delivery network service provided by AWS. It enables efficient distribution of static and dynamic web content, including images, videos, and APIs. So this integrates into using medical records, X-rays that need to be transferred from office locations into the database to fit the patient's needs. And it's always like the ALB and a majority of AWS offerings. It's always using HTTPS. And by using HTTPS, you are reducing the probability of eavesdropping by means of man in the middle. Next slide, please. Then I will be talking about the security at rest when the patient database records on the back end of the cloud infrastructure when they're sitting there. And that is actually one security aspect that used to be overlooked in the past is IT professionals placed a lot of importance on ensuring that nobody was able to alter or change any information that was in the middle of transit. But it wasn't until recently, within the past 10 years, that people started placing more importance on um, data encryption when it's at rest at a hard drive, SSD, and all of that. So the Amazon server-side encryption, S3, they provide encryption by default, and encryption can be changed to fit the needs of the customers. And I'm going to be talking about the Amazon Elastic Block Storage, the security that it provides. So you can encrypt EBS volumes as needed. Um, you are also able to meet the security and audit compliance requirements for HIPAA, especially since our customer deals with patient records. And then there's many different supported volume types: general purpose SSD, provisioned IOPS SSD, throughput optimized HDD, and cold HDD. And along with everything else that has been stated from before, access control is integrated throughout the entire infrastructure. And I will be now talking about the AWS key storage, which is the used in conjunction with the server side encryption. And Amazon key management storage in conjunction with server-side encryption uses automated rotation of encryption keys, and this can be turned on and off. Supports both asymmetric and symmetric keys. You can create your own encryption um, using the customer master keys, CMKs, and you could also use the AWS key management service default encryption keys. And with to caveat off of what we've been trying to push through with our customer, I just thought it would be important to also acknowledge the fact that in the past it has been a problem where hospitals and other medical locations that were storing patient database records were not putting enough capital into ensuring that their IT infrastructure was up to par, and it resulted in many different breaches where people's identity, because patient database records hold not only information about their health but also about billing address, credit card information, and this is all stuff that hackers on the internet really try to take advantage of because they're using outdated and deprecated operating systems like Windows XP, Windows 7. Those are no longer supported, and all the vulnerabilities that are available in those operating systems are able to be seen on the internet and exploited by attackers. And our suggested infrastructure that we're providing for our customer removes the need or the worry about security, as AWS is constantly introducing new technology and they are HIPAA compliant. So all of the technologies that we mentioned in our presentation today is supports that fact. And that will conclude our presentation. Thank you very much for listening. Have a wonderful evening.